One important thing that we're going to need to distinguish in this unit is mass versus weight. So we're talking about kind of what is going on with those and then comparing them. So first of all, remember that we're going to define mass as the measurement of, and this should say mass versus weight. Sorry if that confuses you. Mass versus weight. Mass is the measurement of the amount of stuff, which we can also call matter, in an object. So matter is our technical word. Amount of stuff is our kind of everyday translation. So if you've got, a pile of sand and then a twice as big pile of sand, the twice as big pile of sand has twice the mass, assuming they're the same type of sand, same density, blah, blah, blah. But generally speaking, bigger objects tend to have bigger masses. If there's more stuff there, there's more mass there. Weight is the measurement of the Earth's gravitational pull on an object. So technically you can define the weight relative to anything. And if we're on a different planet, then we'd say, the moon's or Mars's. It's just whatever planet you're defining your weight relative to, you have to pick one, and then it's however hard that planet is pulling on it. So now, if we're near the surface of the Earth, and most of the calculations you'll do will be near the surface of the Earth, the weight, W, is also equal to Fg, which is also equal to mg, where g is the acceleration due to gravity. And m is the mass. So if you take your mass and you multiply by 9.8, you can find your weight. And weight, if you'll notice, it has this Fg. It's the Earth's gravitational pull, so weight uses newtons. And we'll see that in a second. So that's the kind of definition of both. Now let's compare those two. So if I have a table here and I put mass and weight as my two columns, quantity, variable, units, and change. So mass is a scalar, right? It doesn't make sense to talk about, you have 10 grams of stuff or you have 20 kilograms of stuff in the rightward direction. Weight is usually a scalar, although it does relate to the force. So if you want to think about it, weight is kind of like it's the magnitude of the gravitational force. But there are some places where you might see it described as a vector because it's based on that force. The variable we use for mass, we use a lowercase m. For weight, we use lowercase w, or, like we said, sometimes we conflate it a bit more with the gravitational force, so you might see F subscript g here. The units for mass are kilograms. The units for weight are newtons. For changing, mass never changes, broadly speaking, right? If something, unless you break something into smaller pieces, its mass stays constant. However, weight can change if moving away or towards a planet or a moon or something. because as we saw before, the gravitational force gets stronger as you move closer to an object. It gets weaker as you move away, so therefore your weight also gets stronger as you move towards the Earth, weaker as you move away. Let me know what questions you have on this, but otherwise kind of keep running forward with it, and I'll see you in the next one.